My name is Didier from the University of Nebraska-Lincoln. In this video, I would like to introduce to you Dynaplex, a dynamic analysis tool to compute the asymptotic runtime complexity of recursive program. First, we start by showing how to instrument programs in order to collect the necessary traces for the analysis. In this example, I show how to manually instrument Karatsuba multiplication function. We instrument the function entry to collect the problem size and the depth of recursion at each recursive step. We also instrument the recursive calls to increment the depth of recursion as shown on lines 23 to 25. We run Karatsuba function 100 times on randomly generated inputs, and we store the collected traces in file named according to the file naming conventions explained in our tool demo paper. This manual instrumentation process can be tedious, thus with a C++ library to help automate the process of instrumenting C++ functions. In this example, I show how to use this library to instrument pancake sort. All the user needs is to include the header file for the library, and at pancake's function entry, specify the problem size. And for each auxiliary function called in the pancake sort, we need to instrument those functions to track the number of loop iterations as shown on line 29 in findMax and line 42 in flip function. As we can see, this library helps reduce the instrumentation process to about 3 lines of code. Now I would like to show the running Dynaplex on Karatsuba function. We execute the Karatsuba program that's been instrumented to collect traces. Once the traces are collected, we run Dynaplex on those traces. Dynaplex's output can be divided into 3 parts. First, it computes and outputs the recursive terms of the recurrence relations. So 3 terms for 3 recursive calls in Karatsuba function. Second, it computes the non-recursive polynomial relations. And since Karatsuba does not have any loops, it finds that the polynomial relation is constant, 1 versus here. And third, it combines the results of the recursive and non-recursive terms into a recurrence relation, which is then solved to compute the complexity of Karatsuba. Let's show another example running Dynaplex on pancake sort. First, we run pancake sort 100 times on randomly generated list of size from 1 to 500. After we collect traces, we can run Dynaplex analyzer on the traces collected and observe the Dynaplex's output. Similarly to the example before, Dynaplex outputs the recursive terms and the polynomial relations. Here we show that Dynaplex outputs the polynomial models before applying heuristics and the polynomial models after applying heuristics for debugging purposes. These results are then combined into the recurrence relation, which is then solved to produce the complexity of pancake sort. Dynaplex can be accessed by following instructions from the following link. Thank you for your time and attention.